Hello and welcome to Maths with Jacob. This lesson will focus on addition and subtraction special patterns. The subject of mathematics contains patterns that can be fascinating and they can also help us to solve problems. Let's look at some beautiful patterns in nature. I'll bet you recognise what this is. It's a beehive. And you'll see here, if you look carefully, there are some six-sided figures. That's a plane figure and that's called a hexagon. And that's a mathematical shape. And look how beautiful that pattern is. So that's one example of patterns in nature. This here is a tree trunk and it's got all these different circles in it. See that? And when the tree people look at that very carefully, they can actually tell how old that tree is. So that approximates a circle, and that's why it's to do with mathematics, because we know that a circle is a mathematical shape. Here we have a beautiful leaf, and look at that straight line there. And we have many of these straight lines coming here, and that approximates angles. If you look at the way those things come across there like that, you can see a lot of angles happening. So that's also mathematical. And here we have a beautiful spiral. That looks like a shell, doesn't it? And see how that's a spiral? Now we can graph that. We can actually make a picture of that. And that's a mathematical graph which has a pretty complex type of number sentence or equation attached to it. And that's why it's mathematical. Let's look at one famous numerical pattern. So that means a pattern which has numbers in it. The Fibonacci series is one of the most famous mathematical patterns in the world and has many applications in nature. This is how the series starts. If you remember, we did a number line there a few slides ago, and we started with 0. Then the next counting number was 1. Well, that's what we do with the Fibonacci series. But to get the third number, you go 0 plus 1 equals 1. To get the next number, 1 plus 1 equals 2. To get the 3, 1 plus 2 equals 3. To get 5, 2 plus 3 equals 5. And to get the 8, 3 plus 5 equals 8. And that continues on. That's how we build up the pattern. The number of petals on many flowers is a Fibonacci number. So here's an example of a flower with 5 petals. And you see that 5 is a Fibonacci number. And there are many flowers in nature. When you count the number of petals, the number is actually a Fibonacci number. It could be one of the larger numbers, or it could be 8, or it could be 3. The Fibonacci sequence can also be seen in the way tree branches form or split. Now there is if you see here, that's the tree trunk. Now see this little trunk coming out here? We've got 1, 2. See that? There are 2 branches there now. Go to the next level. 1, 2, 3. Go to the next level. 1, 2, 3, 4, 5, and so on. So that's also a beautiful example of a pattern in nature involving the Fibonacci series. Simple patterns involving addition and subtraction. Consider the numbers 9 and 7. Now, add these two numbers together. 9 plus 7 equals 16. Consider the numbers 19 and 7. Now, add these two numbers together. 19 plus 7 equals 26. Consider the numbers 29 and 7. Now add these two numbers together. 29 plus 7 equals 36. In summary, 9 plus 7 equals 16. 19 plus 7 equals 26. 29 plus 7 equals 36. We can see from the above that when you add 7 to a number ending in 9, you always get a number ending in 6. So when you add 7 in each of these 3 cases to any number ending in 9, the answer always ends in 6. These are just 3 examples, and there are many, many more. Consider the numbers 8 and 6. Now, subtract 6 from 8. That is, 8 take away 6 equals 2, or 8 minus 6 equals 2. Let's have a look at the next slide. Consider the numbers 18 and 6. Now subtract 6 from 18. 18 minus 6 equals 12. Consider the numbers 28 and 6. Now subtract 6 from 28. 28 minus 6 equals 22. We can see from the above that when you subtract 6 from a number ending in 8, you'll always get a number ending in 2. So I'll leave you to read that quietly by yourself, and then have a look up here in that example there, and in that example that is the case. Let's look at this example here. Use the numbers 2, 3 and 5 to create number sentences showing that 2, 3 and 5 belong to an addition-subtraction family. Okay, 2 plus 3 equals 5, 12 plus 3 equals 15, 22 plus 3 equals 25. So if you add 3 to any number ending in 2, the answer always ends in 5. 5 minus 3 equals 2. 15 minus 3 equals 12. 25 minus 3 equals 22. So if you have a number ending in 5 and you subtract 3 from it, you'll always get a number ending in 2. And again, there are many more examples of each of these ones here. So when you understand patterns and look at them and work with them a lot, it just makes mathematics a little bit easier.